Welcome to today's webinar, Silage Session 1 on forage quality and how it impacts silage quality and livestock production. I'm Sophia Cusick of the Education Team in Communication and Stakeholder Engagement at the Department of Planning, Industry and Environment, and I will be your host for today. I'd like to acknowledge that as we are meeting across the state in this virtual space, each of us stand upon the lands of many different nations. I'm meeting on Gadigal land, and I'd like to acknowledge the traditional owners of the land and waterway of the Eora Nation and pay my respects to their elders past and present and emerging. I'd also like to acknowledge the traditional owners of the lands and waters on which our online audiences join us from, pay respects to their elders past, present and emerging, and extend that to all First Nations colleagues and guests that may be joining us today. I'd now like to hand over to Sue Street, the Livestock Senior Land Services Officer within Central West Local Land Services, to introduce the session.
Thanks for that, Sophia. I just want to say, on behalf of Local Land Services, we welcome you all here today for today's webinar. This is the first of 4 webinars which will run weekly each Tuesday from 10 a.m. during the month of August. This series of webinars is brought to you by the Local Land Services Ag Extension teams from across the state. We appreciate that across the state, many people are keen to build their fodder reserves, with some areas receiving very useful winter rainfall. Due to this, we are expecting silage to be a good opportunity for producers to utilise excess crop and pasture. We do acknowledge that unfortunately not all areas of the state have been as fortunate as we have, and we hope that rain will be reaching you as soon as possible. So silage is quite a complex activity to undertake. Therefore, we believed it was important that we give our producers practical step-by-step advice in an accessible format. So we're really fortunate that today John Piltz of New South Wales DPI has partnered with us to share his wealth of knowledge and experience in this area of part of this webinar series. So John Piltz is a livestock research officer based at Wagga at the New South Wales Department of Primary Industry. John has more than 30 years experience in animal nutrition and fodder conservation and was the national co-coordinator of the Top Fodder Extension Program until 2005 and is the author of the Successful Silage Manual. So, please, John, we'd love to hear all about forage quality and how it impacts silage quality and animal production.
Thank you, Sue, and thank you, Sophia, and thank you for everybody who's joined in this morning. As they've pointed out, this is the first of 4 webinars, so we'll be looking at forage quality and animal production today. In later webinars, we'll be looking at some of the more practical aspects of making silage in terms of mowing and wilting, harvesting, storage, and also feed out. But today we might have to slug through a little bit of background to silage and the quality aspects so that when we get further down the track, we're all on the same page. Now, as Sophia said, I like it if people ask questions. It makes it a little bit easier for me. Normally one-to-one, there are open questions and I get a breath for a minute, but here, if you could just type them in would be good. And I also have several questions which have been submitted beforehand, which I'll try and deal with today, depending on time availability and applicability, but some are probably better left to later sessions. So what are we going to talk about today? There are several topics that I want to address, and the first one is obviously what is quality. If we're talking about quality, we need to be on the same page with using the same terms. I also want to give a brief outline of what actually happens when silage ferments, the effect of forage quality and silage quality on livestock production, and also want to talk about some differences between hay and silage. And I understand there have been some questions submitted on that topic and some specifics about silage quality, fermentation quality, which I'll do in that order. I'd also like to start by mentioning this manual, the Successful Silage Manual, which, if you type it in Google or one of your search engines, you will find it on the department's webpage or the Dairy Australia webpage, and it covers a lot of the topics that we're going to do today in greater detail, plus several others. But if we move on, the first thing is, what is feed quality? In my opinion, for beef and sheep meat producers, the key components that we need to think about are, firstly, dry matter content, which is everything that is in that forage or silage or hay except water. And the reason we want to know about dry matter content is that all the energy, protein and minerals, which are what allow the animal to maintain live weight and grow, are all contained within that dry matter. So water itself is not a nutrient, but it is extremely important when you come to sell, to buy, or to formulate rations, so that you make sure that you're feeding dry matter, not dry matter plus water. So for example, 10 kilos of hay at 90% dry matter contains a lot more dry matter than 10 kilos of silage at 50% dry matter. So you need to adjust your rations accordingly. The second one is energy, and I'll use the term metabolizable energy. The third of those characteristics is protein content, which I think we're all pretty aware of, and finally minerals and vitamins. Now, in most cases, minerals and vitamins won't be tested or measured, but we need to be aware that in some feeds they're a little bit low, and they need supplementing, for example, grazing cereals, but I'm not going to talk about them in any detail. So, metabolizable energy. I think this is the most important of the aspects of a feed quality, because metabolizable energy is the energy that is available to that animal for maintenance, for heat production, and for growth, milk production, wool production, and sustaining a pregnancy. In most cases, ME, or metabolizable energy, is the first limiting nutrient in most ruminant diets. Often we hear about protein, and there are some examples where that's the case, but generally it's energy content. And we actually measure energy content in what we call a metabolic chamber, which is a fancy arrangement where animals are essentially in a confined space which is hermetically sealed, and the amount of energy they consume, the amount of heat they produce, the amount of gases they produce are all measured to determine how much of the energy is used for growth and maintenance. We can't really measure ME directly very often, so we measure digestibility, and for all your feed test results, metabolizable energy will have been calculated from digestibility. It's not measured per se. And you'll see there are three different equations that we use. And you'll say ME, the top one for silages, forages, ME is 0.203 times DOMD minus 3.001. DOMD just stands for one of the measures of digestibility. So digestibility, again, it's pretty simple. It's how much of the feed dry matter is digested by the animal under set conditions. So you can see from the example there, which comes out of a grass feed manual, that if a cow eats 10 kilos and passes 10 kilos of dry matter, and there's 3 kilos of dry matter excreted in the feces, then we say that it's 70% digestible. There are several measures of digestibility, but the one we prefer to use is DOMD, and it's the one that you'll see on your feed test results. Why is that important? Well, put it in perspective, I calculated this out using grass feed. And you can see there that on the left-hand side of the axis, we've got live weight change in kilograms per day. And we have two bottom axes. One's metabolizable energy and one is organic matter digestibility on a dry matter basis, which is DOMD, the one I mentioned before. As you can see there, that feeds that maintain weight have to have a digestibility of about 55% or an ME of about 8. But for every increase above that, you'll actually get an increase in live weight gain. Because essentially what's happening is up to 55% dry matter content, all the feed that's metabolized is used to maintain live weight. Everything after that is used for growth, which means that what we see is for every minor increase in digestibility or ME, we can actually get a quite substantial increase in live weight gain. In this example, you'll see that for every 1% change in digestibility between that 55 and 75%, or in ME between, it will equate to about 74 grams per day in live weight gain. 74 grams per day doesn't sound like much, but if we think about that, what it has over the implications with a major change, it's quite substantial. Alternatively, if you say increasing ME from 8, which is maintenance, to 12, which is less than most grains, it's worth 1.5 kilos, or just under 1.5 kilos per day. This graph is a silage feeding graph where live weight gain is expressed on the Y or left-hand axis as kilograms per tonne of silage dry matter fed, with megajoules of energy, ME, on the bottom axis, the x-axis. You'll see there that about, in this example, the line of best fit, about 8, live weight gain per tonne of silage is pretty low. It's less than 50 kilograms. But once you get up to 11, you're looking at 150 kilos per tonne of silage dry matter fed. So an increase between 8 and 11 is going to give you an extra 100 kilos of beef produced for every tonne of silage dry matter you feed. So we don't want to leave the lambs out, and you'll see here I've used the same example as 2 graphs ago, and that if you increase live weight gain, if you increase digestibility by 1%, DOMD value by 1%, that equates to an extra 14 grams per day in crossbred lambs, about 30 kilos and 6 months of age. So pretty typical of the type of animal that people will be looking to feed. So, firstly, metabolizable energy is the major nutrient limiting in most cases. It's calculated for digestibility, and small changes in digestibility can lead to large changes in live weight gain. We'll look at a few graphs later which we've got some more data on. The second parameter we need to think about is protein content, because essentially what we need to do is ensure that there is sufficient protein to meet the animal's needs for the amount of energy that they're consuming. Additional protein is not of no real value to an animal, so we just need to provide sufficient. Again, we calculate out a value called crude protein, which is what you would have on your feed tests, which is simply calculated by measuring nitrogen content and multiplying it by 6.25. The reason we do that is pretty simple, because it's when nitrogen is consumed, when protein is consumed by animals, much of that is broken down into nitrogen to be used by microbes within the rumen to help break down the feed. They then reform protein as part of that procedure, and that is the protein which animals use, apart from a small component that passes through undigested. So essentially, the best estimate of protein for a ruminant is crude protein. Okay, so they're the two main things that I believe we need to look at. Firstly, energy content and protein content when we look at quality. If we slip over now to silage making, what are we trying to do? We're trying to take forage in a wet form, not dry like hay, and put it in an airtight environment and preserve it due to a fermentation process. So what happens is bacteria under anaerobic conditions, that means no air, convert WSCs or plant sugars to acid. The acid then lowers the pH of that silage and it's essentially preserved. It's similar to pickling, similar to putting vinegar on something and pickling it. The amount of acid that needs to be produced is affected by a thing which we call buffering capacity, and that dictates how much of the sugar is required to produce acid to counteract the buffering capacity. So, for example, something that buffers really well requires a lot more acid, therefore requires a lot more sugar. There is a scale, and in practical terms, the buffering capacity ranges from about 100 to 150 for really easy to ferment materials like maize forage, all the way up to over 1,000 for some of the broadleaf wheats. We need to be aware of that because we're looking at buffering capacity and sugar, how much sugar we need. Now, one option we can do is when we make silage, we wilt the material. That increases the dry matter content, which concentrates the sugars, which makes them more available to convert to acid, to have a bigger impact on the amount of acid produced, and that helps to lower the pH. Unfortunately, if we have wrong bacteria dominating the fermentation, that causes a poor fermentation, which causes a foul smell. It breaks down the protein, which makes it less usable. You lose quality, you lose dry matter, and you lose energy content. And more importantly, you often get a very low intake because the animals don't like it. If we, on the other hand, increase dry matter content, we actually favour good bacteria, which means that the wrong bacteria can't dominate that fermentation. So therefore, if we're looking at making silage, there's three key components that influence the quality of the fermentation per se, as opposed to the quality of the forage. And they are WSC, or water-soluble carbohydrate, dry matter content, and buffering capacity. So if we look at those in a little bit more detail, you'll see that water-soluble carbohydrates are converted to lactic acid by lactic acid bacteria, the same type of bacteria that's used to make yogurt. Now, there are two types of lactic acid bacteria, those which we call homofermentative, and all they do is create lactic acid from sugar. They're the most desirable in terms of there is no energy loss and the fermentation is quite rapid, leading to a low pH and stability. There are some, however, which convert sugar to lactic acid and other products. They're less efficient, but are increasingly being used because they can improve the aerobic stability of silage, which is how well it stays without heating once it's exposed to air. Now we'll talk about that in detail in the fourth webinar when we look at feed out. The ones we want to avoid are firstly the enterobacteria. These are not necessarily responsible for an incredibly poor silage fermentation, but they're very inefficient. They use sugar without producing much acid, and they do produce or tend to produce a lot of acetic acid. So if you have a silage with a vinegary smell, that's probably one that's been dominated by enterobacteria. And they like warmer conditions, and they therefore can be more dominant, particularly in the warmer areas of Australia, and it's not unusual to see them in tropical silages. The bacteria we really do want to avoid, however, are Clostridia. Now, they're all related to the Clostridia that we vaccinate against with 5-in-1. Clostridia are not wanted because they either break down sugar, break down lactic acid, and they break down protein, or all three. So rather than the sugar being available to produce lactic acid, the sugar is broken down into things like butyric acid, which literally smells like vomit, and other products like carbon dioxide, and is no longer available either as an energy source or as a source of sugar for producing more lactic acid. In some ways, though, the worst thing they do is they break down proteins. So if you can imagine that in forages, most of the nitrogen is in the form of protein. About 80 to 85% is protein, and the rest is other lesser forms of protein. However, Clostridia, if they act quite a long time, they can break that protein fraction down and end up, at its worst case scenario, producing ammonia. Ammonia is highly degraded protein. We don't like ammonia because of two reasons. Firstly, it means the protein fraction is degraded and becomes less effectively utilized by the animal. But secondly, it's highly unpalatable. And you can imagine that if a forage or a silage contains very high levels of ammonia, it's both smells and it's not a pleasant smell and not a pleasant taste. And we'll look later at some measures of that. And the last one we talk about is yeasts. Yeasts are the same as those that you get when you make beer or wine. Rather than produce acids, they produce ethanol. So the sugar is converted to ethanol. There is no net value in the ethanol because it doesn't produce any reduction in pH. It's not an acid. More importantly, ethanol is very easily broken down when exposed to air by yeast and other bacteria. And also, if you have a fermentation with a lot of yeasts, it means that those yeasts will be present when you open up the silage, and those yeasts will continue to function, and they will start breaking down available sugars and other products quite quickly once they're exposed to air, and you'll lead to instability. Now, that's a pretty quick snapshot of the silage fermentation process and the bacteria and the yeast that may be present. We've also had a snapshot of the forage characteristics that might be important. So we'll now look a little bit more detail about the impact of some of these forage characteristics. In order to get a fermentation that's for lactic acid bacteria, LAB, to dominate, we really want sufficient sugar content, WSCs, and what we do say, and this is the only example where we will talk about fresh forage, we require a minimum level of about 2.5% of the fresh forage, because below that there is a risk of a poor fermentation. You can increase this with wilting, as I mentioned before, and it also varies with species. So sugar content, for example, is lower in clovers than it is in grasses. Maturity, sugar content varies in cereals. As they become more mature, the sugar's translocated into the grain and to starch. Weather, time of day, sugar content is higher in the afternoon. Sugar content is an outcome of photosynthesization. So when the plants are exposed to sunlight, they use carbon dioxide to produce sugars. So overnight, there is a breakdown in sugar because there is no sunlight, and the sugar is used by the plant for respiration. But during the day, the sugar levels build up again. And there's also an effect of nitrogen fertilizer. the cause of which is not really known, but if you apply a lot of nitrogen fertilizer, it will reduce the amount of sugar that's available and can have impact. So therefore, we never advise fertilizing just before making silage. Buffering capacity, which I mentioned before, is the ability of the forage to resist a pH change. If it is high, we need to produce more acid, which requires more sugar. It tends to be lower for grasses compared to legume. So we're talking ryegrasses in the range of perhaps 4 to 450 units, as opposed to legumes 7 to 850 units. It's higher for leafy, vegetative, less mature plants, and it declines as plants become more mature. So therefore, older plants are easier in terms of buffering capacity to ensile, but we'll see shortly there's some problems why we don't want to go down that pathway. Broadleaf weeds are probably the biggest concern, because values of over 1,000 up to 1,300 have been seen in terms of buffering capacity. So if you've got a crop that's heavily dominated, for example, with capeweed, then be aware that that capeweed will be silage of that capeweed will need to produce a lot more acid to get a pH drop. Fertilizer can increase buffering capacity, and wilting can reduce buffering capacity, but they're difficult to quantify and you can't really guarantee them. So what you'll see if you log on and have a look at that manual, you'll see in there we have a table or a chart which we call forage insolubility. So you'll see that some down the left-hand side, we've got plants or forages divided into low, medium and high buffering capacity. And we've got along the top, forages divided into high, medium and low sugar content. So obviously, something's got a very low buffering capacity and extremely high water-soluble carbohydrate or sugar content, like sweet sorghum, is very, very easy to ensile. Something that's got a very low sugar content and a very high buffering capacity is very hard to ensile. And you'll look there and you'll see that there's a lot of the plants we want to deal with that are in that difficult to ensile. Now, if we think back to the three components that affect of the forage that affect the silage fermentation, the sugar, the buffering capacity, and the other one is dry matter content. Now, we'll look at a couple of aspects of dry matter content in a moment, but effectively, once dry matter content exceeds about 30%, so 30% dry matter, 70% water, or drier, the really undesirable bacteria tend not to be able to function very well, and they don't dominate. So we have a tool which is wilting, which allows us to manipulate the fermentation, because we can manipulate dry matter content, which leads to a manipulation of the dominant bacteria. Bear in mind this table though, because what you will see there is, if you look at, for example, Italian ryegrass in the middle, and it's moderately easy to ensile. It's in the middle. If you look at lupins, or you look at grain, winter cereals that are more mature, same deal. They're relatively easy. So that means we can be close to that 30% dry matter content, or just above that 30% dry matter content, and there's very little risk. However, if we're down in that very difficult category, then as a rule of thumb, it's better to have dry matter content higher rather than lower, which is why we recommend a minimum dry matter content of 35% for chopped silages. Now, bales are obviously different, and we'll talk about them later, but 35% and even up to about 40% if you're looking at some of the clovers. And why? Let's look at how dry matter, what the impact of dry matter content is. We say too wet, and too wet, I'm going to say less than 30%. Ideal, I'm going to talk about chopped silage, so I'm going to say about 35%. And too dry, I'm going to say over 40% for chopped silages with a couple of provisos. What you can see is, if you look at that table, if it's too wet, you run effluent. And we'll look at some losses in a minute. But effluent is the liquid phase that comes out of a pit when it's made too wet, and most people would say, so what, it's water. Well, in fact, it's about 10% sugars and proteins and some minerals and vitamins. So it's actually highly digestible. The dry matter content that's dissolved in that liquid is highly digestible, but more importantly, it's material that if it was to enter a waterway would be an extremely bad pollutant. It would lead to a lot, it would be a very bad pollutant, and you would need to make sure that somehow you manage it. Okay, and I'm just getting a question here, which I will answer shortly. So yes, so effluent loss. We don't have any issues at the moment in Australia. We can normally do a pretty good job, but certainly in countries like Europe or places like Europe and the UK, where ensiling of wet material is common because it's difficult to wilt, effluent is a big issue and legally must be kept on farm because of the risk of it as a pollutant. Fermentation quality. Now, if it's too wet, at risk. It's at risk because of that fermentation being dominated by the bacteria we mentioned before. If it's too dry, it's at risk because it's often more likely to be dominated by things like yeast and molds. And the reason being, if you look at the next one, ease of compaction. You can imagine if it's wet or ideal, it's pretty easy to compact. But as it becomes too dry, it becomes difficult, becomes spongy, air gets trapped into the silage. That air continues to let the plants respire. It allows things like yeast and molds to start to grow, which potentially leads to issues with the silage quality and the fermentation quality. But more importantly, once those molds and yeasts grow during the ensiling phase, they're there when it's time you open, and we'll see in the fourth webinar that when they're present, it leads to instability and less favourable outcomes for animals. The other one we'll look at shortly is the impact of wilting on field losses, and simply to say that the longer you wilt for, generally the greater losses you get, and that's going to have some implications which we'll see later for hay and need to be considered for baled silage. So next, I'd just like to touch on a couple of points here because some of these get thrown up as favourable for making silage. The first one I'd like to say is silage does not improve energy content of pasture. Similarly, silage doesn't reduce protein content. There may even be a slight increase in protein content of pastures or any of the forages, but it may change, or it will change the form, and it may change how efficiently it's utilised. I do sometimes hear ensiling may increase palatability. As a general rule, it doesn't, but there are a couple of examples where that is not necessarily the case. And one that, for example, is Yorkshire fog, which tends to be unpalatable and tends not to be grazed when it tends to be avoided when it's grazed, whereas when you put it into silage, it's consumed without any problems. But the other one I do want to say is fermentation quality has a big impact on intake. And we'll look at some results of that both later here, but also further down the track. But definitely, as I said, I mentioned the example of high ammonia content. Worst case scenario, I've seen silages with ammonia contents where 30 to 50% of the protein has been degraded into the form of ammonia. So if you can imagine something with a crude protein of 15% and half of that crude protein is in the form of ammonia, it's not a very nice product. Righto, so let's get through a bit of the nitty-gritty about making silage. And we will get on to why is silage quality higher than hay quality. And there are 4 components, and they fit neatly with the 4 webinars, where forage conservation has an impact on the quality of the product that you end up with. Initially, crop and pasture quality is the first phase. And you'll see there from this diagram there that there is no way to increase quality. Quality declines at every stage. It's unavoidable that there are losses and there are reduction in quality. So what we're trying to do is we're trying to start with the highest quality product we can and minimize the quality losses as we go along. You'll see that the spread between, in terms of the quantitatively, the spread in losses gets bigger the further down this system, and you'll see why later on. So really, we need to start with a high quality product. If we start with something that's pretty average, then we're never going to get any better than pretty average. What then affects quality? What's the most important thing that affects quality? Well, this again is another diagram and we can talk through it, but it pretty much identifies the different types of forages that we deal with. And you'll see there that as they go from vegetative through the reproductive stage, flowering up until grain fill in the case of the cereals, there is a decline. So all of the forages tend to decline across that period of growth as they become more mature. You will also notice that there is a difference in starting quality. So as a general rule, when they're vegetative, temperate legumes are higher quality than lucerne, which is the green line, which is higher quality than temperate grasses and oats, which is the blue, which is similar to, but slightly higher perhaps in barley and wheat, and the tropicals, unfortunately, are last. You'll also notice that as they become more mature, some of the species lose quality more quickly. I'd also like to point out, so that gives you a bit of an idea of what you've got to work with, but I'd also like to point out that barley and wheat there, you'll see that you can have a rise in quality, and we're talking about metabolizable energy content. That's associated with grain fill. Now, whether or not that upkick again, that slight increase in ME occurs will depend entirely on whether or not there is enough grain produced. And we'll look at some examples later on. So if there's very little grain produced, then don't expect that to occur. Think it's going to be more like an oats and just continue to decline. So what we've got here is some examples from species that were grown at Wagga. And you'll see there are 2 types of oats. There's Cooper oats, which is down the bottom, and Calgan oats, which, is very, very, it's very similar to the vetches and the peas and the starting point. And also you'll notice that ryegrass was the best in this example. It had the highest digestibility. So this was harvested at 3 stages. The 2nd of October, which is probably consistent with a silage, the 23rd of October are late silage, 6th of November are hay. Typical timing for hay. What you see is they all declined in quality over time, though in the case of peas, the decline in quality was relatively less, particularly initially, and then a slower decline afterwards. If we look at some legumes, just some Clare, some Sub, Balancer, Arrowleaf, and Barrel Medic, you will notice, again, if you can think back to the starting point before where ryegrass is about 75% digestible, they're a little bit higher, which is consistent with that clover being higher. What you'll also notice is the rate of decline there is relatively less than you did see for the grasses, with the exception of Balancer. And Balancer declined quite quickly, which I interpret is a result of Balancer having a relatively high stem to leaf ratio, and stem's less digestible as it becomes more mature. But it certainly means that, yes, initially quality is high, but you really need to be aware of what you're working with to see what the impact's going to be as they get more mature. Putting this in perspective, and remember I mentioned about these dates being similar to early, late, silage and hay. Got some data here which is European data, and it's for ryegrass, and it's made into silages. And it's over silages produced from ryegrass, which is cut over 28 days. So there's an early cut 14, and a cut 28 days later. First thing you'll notice there is that as it becomes more mature, intake tends to decline. There's not much difference between the last two, and it's a little bit higher for late, but there is a decline from early to late. And that is typical of what happens as digestibility declines. And you'll see that digestibility has declined from almost 71% to 58% over 28 days. And so therefore that quality decline is mirrored by an intake decline, because not only is the material, what happens is not only is the material less digestible, it is digested more slowly, which means that they are full and they can't eat as much. But see what happens, live weight gain. At the early cut, it's 1.14 kilos per day, and it declines to 0.44 kilos over that 28-day period. So 700 gram reduction in live weight gain over 28 days. I use a rule of thumb, which is for these type of forages, which are grass to temperate grass type silages, the quality probably declines about 0.5% a day. So think about it. We go back to what I said before, 1% equals 74 grams per day in steers. So every couple of days you lose 74 grams. So you can see that delaying harvest from early to late is what leads to a big reduction. Now, when people say silage is better the quality than hay, really what they're saying is silage is produced from much earlier cut material when the quality is much higher, which means that the quality feed value of that silage is higher than produced for hay if it was cut from the same pasture or same forage crop, if you can follow. Now, there is an impact of extended wilting on quality, but the main impact which determines why a subclover or a ryegrass pasture silage is higher quality than hay made from that same paddock is the time at which it's cut and the quality of the forage which it's cut. It's nothing to do with the ensiling process per se. It's got nothing to do with fermentation quality. It's purely a forage characteristic, and it's why it's important. To give you an idea of what sort of things we can see, these are just some results from 17, 18 and 08, 09, and I don't want to spend much time on them, But if we now look at wheat and canola, which are quite common in terms of the last couple of years and sort of earlier in the drought, wheat and canola silages are extremely common. And you'll see there that the value that I've got in 08 and 09 and 17 and 18, they're the MEs 9 and 7.9 and 9.2 and 9.2. They're the averages. But what I really want to show is the range. And if you look below that, you'll see that the poorest quality was 5.2 and 5.7 in 08 and 6.5 and 5.3 in 17-18. The second, whereas if you produce the highest quality, they're incredibly high value forages in terms of ME in wheat in 08-09 and wheat and canola in 17-18. Canola in 08-09 didn't. Now, that gets to a bit of an issue of when should we cut both forages. With canola, I think the data has shown now it's pretty obvious that if you cut early, you will have an extremely high quality product which has got a really high protein content and is very, very useful. Every time you delay, that really has an impact on the quality, and at no point does it appear to decline, to go up again. It's just a continual decline. That's what we've seen. Granted, canola is usually cut in a drought year, but I don't think it is going to make much difference. You could ask about, if you cut later and there's some oil there. Firstly, over a certain percentage of oil is not good for rumen function anyway. But more importantly, canola seed's pretty small, and particularly for cattle, I would guess a lot of that would be excreted. So it might show high energy content because of the oil, but if it's not utilised by the animal, it's worthless. So in terms of wheat and canola, and I would go so far as saying barley, I would talk about cutting early as being the ideal stage. If there's a huge increase in yield and there's a kick up in ME, you may very well get it may very well offset, but in my experience, in most years in Australia, if you want forage quality, go early. It's a safer bet. Now, one of the questions I've had is looking at when to harvest barley for both yield and quality, particularly if you're looking at using it in a feedlot ration. As a follow-up to that, which also says, has any correlation been done between sugar levels, a Brix reading, which is what the wine people use, levels in barley, and composition of energy, protein, and digestibility? Well, I'll answer the second bit, not that I'm aware of. I have heard of someone playing around with it, but I don't know anything. In terms of barley, the correct time to harvest barley is, if you want a high quality forage, I would always recommend going at the boot stage, which is when you've usually got sufficient bulk there to make it worth your while, and you haven't entered that quality decline. Alternatively, the recommended time to harvest barley and also wheat, if you're specifically looking for a feedlot diet which contains a proportion of lower quality roughage and higher levels of starch, you would cut when that crop is at about the soft to mid dough stage. The rationale being that what you've effectively done there is you've gone for immature grain, which still has a lot of starch, plus your straw component, which is the stover component. Now, what's the best is really going to depend on what you want to do. But in my opinion, if you're not in a feedlot, you wouldn't delay that stage. If you are in a feedlot and you do delay that stage, one of the advantages is you don't have to wilt. So it becomes a direct cut option. The dry matter content at that stage is about ideal because the plant has naturally dried down with maturity. It reduces the losses because it becomes a direct cut option. But in terms of maximum quality from a forage diet, you're probably behind the 8 ball a little bit, but you may have more yield if you're prepared to put it in a feedlot ration and maximise growth with more grain and other supplements. It's probably fine. But again, really going to depend a bit on the crop you're working with, and get some testing on it. We've also got one here about the quality of bicerula silage. Bicerula is a new legume and appears to have lots of advantages in terms of production, particularly in the drier areas. But for those of you who don't know it, but very little's been done with bicerula in terms of conservation. If you look at it, it probably is not suited for hay because it's a very fine-leafed plant and likely to suffer extensive damage and loss when you're handling it. But other than that, the only recommendation or advice I can pull out about bicerula is to say that if you cut it early before it gets too stemmy, you've got generally a high quality product, and I doubt it would behave really much different, but we're not sure, to most of the legumes. The issues, potential issues with photosensitization seem to be ameliorated by cutting. The compound seems to disappear quite quickly after cutting. So quality of silage at this stage, I would say, assume it's similar to just any other legumes. But would like to contact you. I know Belinda has, and we'll talk about whether we can get some samples and do something. On that cereal, and one of the reasons why I said what I did is I wanted to show you some results here, and these were ones that were done in Wagga in 08 and tomorrow in 10, where we grew the same 7 cereals, 2 wheat and 2 barley and 1 triticale. And these are averages. So 08 was an incredibly tough year. Yields are very, very low, as you can see, whereas 10 was one of the best years I've ever seen, and yields were exceptionally high. You can see there that in the tough year, in 08, crude protein content tended to be higher and at all stages than in 10, when it was a really bumper crop. As you'd expect, quality protein content declined over time. If we look at the right-hand side, the interesting one there is ME content. Metabolizable energy content started off in 2008. That was incredibly high. So 12.5 is effectively close to barley grain. Whereas in 2010, it was only 9.9. In both cases, it declined. But a couple of key points that come out of that. Firstly, same stage of maturity, massive difference between years in terms of ME. I would argue that most years, your normal year, if we ever have a normal year, is probably somewhere in between. The second thing I'd like to point out is that while the decline occurs in all years, you still end up with a really high quality product in 08 in terms of ME, but not so in 2010. One of the reasons that I attribute that high ME content is to the amount of sugar. Now you'll see the sugar contents of those crops in 2008 were extremely high, whereas those in 2010 were more normal or lower than you would normally, slightly lower than what you would expect. Now, if you do your sums and you talk about whether you cut early or you cut at that later stage, firstly, you'll notice that in the first year, things are tough. You didn't get much yield increase. You got a yield quality decline, but it's still very high quality, but there was really not a lot of advantage in terms of delaying when you utilise that crop. Whereas in 2010, there was a significant yield increase from a good season, but ME declined to the extent that at that milk stage, it's not a lot better than a maintenance ration. if you say cattle lean an ME of 8, 8.7, they're only going to grow very, very slowly. And the protein content is borderline. I mean, it's a bit low. For a production ration, it's too low. So in both those cases, whether there was a yield increase or not, there was no advantage in delaying. So I would say, based on this and similar stuff we've seen before, firstly, your average is going to be somewhere in between those, but there's never a reason why I would advise anyone, excepting for the example of the good quality wheat or barley into a feedlot or a dairy type ration. But in a straight typical silage on farm, I would say that's the safest option to take in terms of ensuring reasonable quality, rather than banking on the amount of any benefits for potentially increasing yield and increasing yield per hectare of the forage crop. There's a question here. What's the buffing capacity of brassica? High. It's up there. It's probably 800, maybe higher. Could be over 1,000. So again, brassicas are one that you really got to make sure that you wilt properly, and one that I would suggest you wilt to at least a dry matter content of 35. One of the pluses, if you think about it, those plants like brassicas and clovers and that need to ensure you get over 35% dry matter content, they wilt really relatively easily compared to some other plants. But more importantly, even at those higher dry matter contents, they're relatively easy to pack because they can be sticky. They don't have hollow stems, with the exception of, say, Balanza and similar. They tend not to have hollow stems. They tend to be sticky and pack together pretty well. Another question, and I might just slip on. There's a couple more questions, but I might slip onto this one. So we talked about losses, and effectively, look, you can see a lot of this in the manual, and we will do some losses during the wilting and harvest session next week, and we will definitely do losses during the feed out, the 2 weeks later. But losses during storage, essentially, if you keep it and store it, and there is no air or no water enters that pit or that bale, then there shouldn't be any losses during that storage phase. I want to put those into a little bit of context. I mentioned too wet before and too dry. Now, this table, or this figure, sorry, is in the manual. It's an amalgam which is trying to put together the dry matter losses from different components of the system at different dry matter contents. And it starts assuming wilting, direct cut, 15% dry matter material, which is what used to occur many years ago. And you'll see there that, as I mentioned before, that first lot, the losses under the green line, is the effluent losses, and by about 30% they decline. The losses between the green line and the brown line are storage losses, and they tend to be reasonably constant, though a little bit higher at the bottom end, and certainly a little bit higher at the drier end, which is due to essentially more air penetration and a few things like that. If you look at field losses, you'll also see that field losses go up as the material gets drier. And that's for two main reasons. Firstly, respiration. So as the plants are wilting, they're still alive, they'll respire, so they'll lose sugar and dry matter content. That slows down after about 30-35% dry matter content and ticks away slowly, but at that stage mechanical losses start to become more important. So as the material dries, it becomes more brittle, and every time you rake it or ted it, it will lose some material, and some of that material will be lost forever. And unfortunately, it's usually things like the leaf, which are higher protein, which are more brittle and are lost first. So you can see there that the lowest total losses on the blue line are probably around that 35%, just under. So that around that typical chopped silage area. Now, I'm aware that baled silages are normally produced at about 50%. My opinion is that I understand why that's the case, and I can see reasons why that's the case, but I would not support going too much. So there are people that would make baled silage, square baled silage in pits and come back at 45% and be quite happy with that, whereas some people choose to go out to about 60%, and my comment would be the product looks fine, but you've probably lost material that you didn't need to lose if you'd have produced that bale at about 50%. So in terms of optimum dry matter for baled silages, my personal view, if it's bales, square bales, I'm happy to see you come back to about 45%, and certainly 45% in pits where you've got some stability. One of the issues with being too wet with bales is stability if they're stacked, particularly if they're stacked in modules. They can get heavy, they can slump, and you can get losses. But if you've got them and the bales well formed, they're nice and tight, it's not really a problem in terms of instability. I think that you can get away with 45%. With round bales, same sort of answer, but for God's sake, stand them so that they're on their flat side. And the reason why you would stand them on their flat side, and we'll show you some pictures in the third webinar, but the reason being that if they are wet and they get heavy and they start to slump, the sides will tend to collapse on them, and that will tear the plastic, so the plastic can become brittle and break. Whereas if you stand them on their flat end, that slumping won't occur. More importantly, you've got more layers which give you a barrier against the soil surface, which, for things like bugs and whatever crawling in, and you've also got more layers at the top, which presents a better outcome in terms of sun damage, UV damage. So UV will eventually break down plastic wrapped bales, and wrapped bales are therefore generally said to have a storage life of about 12 months, they're guaranteed. So that's why. Now, if we, I'm trying to do some questions as we go here, but as you can see, losses go up as you get drier. The other thing to note there is as weather conditions deteriorate, so their weather conditions are poorer, you'll get greater losses. And that'll come about for a number of reasons, but firstly, it'll take longer. So, you can see there to get to 20%, it only takes about a day, up to a day. Whereas if you're trying to get very, very high dry matter contents, almost to the hay stage, it's going to take you 3 to 8 days to get to about 80%. What happens when weather conditions are poor? They tend to be overcast and maybe light showers and things. The material stays fresher for longer, which means any respiration that occurs is more prolonged. When plants are cut, they're no longer producing sugars, but they're still respiring, so they're still using the sugars that they've conserved from before. That will continue until they're all used up or dry matter content is too high for the enzymes in the plant to respire. If it's overcast, rates of wilting are low, that respiration will go on for longer. The other thing is they're ideal conditions for the growth of molds and yeasts and other compounds. So that's why poor conditions lead to greater losses. So again, if conditions are good, you can make silage very, very quickly, but if conditions are bad, it's more difficult, but it certainly means that hay is out of the out of the question. Now, what I've got here, which is also in the manual, is a table which shows typical forage conservation losses. So we're talking about that wilted silage versus hay. And you can see there that the losses, you're still going to have those losses in the field that I mentioned before, 5 to 8%. Whereas, but hay, because it's drier and you've got more mechanical loss, you're going to be looking at 20 to 25% losses. Now, in terms of storage, you'll see there that we're talking, the figure that's quoted there is 6 to 7% losses. Now, that considers that under previously, silages were made and allowed to ferment naturally, and a portion of the dry matter was essentially converted into carbon dioxide, heat and water as it fermented. With the advent of bacterial inoculants, particularly the homofermentative lactic acid bacteria that drive that fermentation very quickly, losses due to fermentation have been reduced. I haven't seen any really good figures on it, but I know there are claims that it can be as low as 2% in some cases. Interestingly, hay stored in the shed, you're still going to get some losses, but if you store it outside, they're going to be horrendous. Feed out, now those losses are again looking at a reasonable system, and we'll talk about them in more detail later. So, hay versus silage, and I'm nearly finished except for some questions, but hay versus silage, pretty simple then. Silage is less prone to weather, so therefore you can cut earlier and you can maximise the quality of the forage when it's at its peak or close to its peak. You've got less field losses. However, you do have a risk of spoilage if air gets in, and the same for water. The other thing I'd like to say is, or reiterate, is that palatability can be reduced if fermentation quality is poor. Couple of last slides that I want to show before that. First one is I've got some more hay and silage data, this is West Australian data, and it looked at hay or silage produced from annual ryegrass subclover pasture from two adjoining sections of a paddock. Obviously, the difference was in terms of when they were cut, with one being cut at about the 10th of October and the hay being cut at about the 6th of November. And they were fed with some grain in the diet. What you can see there is, regardless of how much grain they had, the live weight gain from the silage treatment was always higher than the live weight gain from the hay treatment. The proportional of additional gain may not have been constant, but to a degree that's understandable, because as grain increased as a percentage of live weight, grain became a more significant part of the ration. So at 1.5% grain fed to the hay, that would have been over 60% probably of what they consumed. So it dilutes the effect of the hay versus the silage quality. But you can see there, a practical example, why we end up with these figures that say silage is better than hay. Finally, I want to just show you a couple of tests. I mentioned the silage fermentation quality as being the additional factor which can affect intake and utilisation of the protein, even though feed test quality in terms of ME and crude protein can be fine. There's two tests we do. The most valuable one, as far as I'm concerned, is that silage ammonia, which tells you how much of that nitrogen was degraded. The other one is silage pH, and we'll have a look at a table now which shows, again this is in the manual, which shows some indicative pHs for silages produced at different dry matter contents. Now, the first thing you will notice there is that it only goes up to 35%, which is where we go with chopped silages generally, or a little bit higher. You'll also notice it's a little bit lower than grasses. So it's an indication that if you've got a higher pH than that, probably got a poor fermentation. You don't have to worry about the bale silages so much because it is so dry. The dryness knocks the bacteria around so they can't ferment as effectively. And effectively, once you get about 50% dry matter content, there is very little fermentation. So there's very little pH reduction from acids being produced. Really what you're looking at when you get up to dry matter contents of about 50% is basically storing material in a wet form, wrapped in plastic so the air can't get it, and that exclusion of air is what pretty much preserves it rather than production of acid, because that's minimal. It also explains why, and I've often heard the comment, it's really beautiful silage, it smells really sweet. And bale silages often smell sweeter than those from chopped silages. The sweet smell is purely and simply sugar. It's the smell of sugar. If you think it's the same reaction as producing yogurt, with the bacteria produce lactic acid like yogurt. Now, I'm not a yogurt eater, but I know yogurt doesn't taste sweet. Lactic acid isn't sweet. So, yes, it's a nice product, but that's why it's a nice product. What I think is more important is to look at how much that protein is degraded. And if you do a feed test, they will give you these figures. So if your ammonia nitrogen as a percentage of your total nitrogen is less than 5%, I would say fermentation quality is excellent. If it's in the range 5 to 10, which is pretty reasonable, it's good. 10 to 15, not so great. And certainly by that stage, you would see a reduction in intake because of the fermentation quality. And greater than 15, it's poor. And as I said, have seen them almost 50% ammonia. So they're terrible. So when you do your feed test, if you're feed testing silage, it's worth getting this additional test done, or doing the silage packing, getting the pH and ammonia nitrogen done. They come as a package, and that will allow you to make an assessment of whether or not your silage fermentation quality is excellent or good, in which case intake should be reasonable, and the lower it is, more closely related to the forage it was made out of. Whereas if you up around that, more than 10, certainly more than 15, don't expect the same level of production without supplementing with grain or some other factor. Now, finally, I would chuck up one more test. In the event you've got browning reactions that really concern you, the materials become really hot, they heat, and this can be hay as well as silages. Now, ideally, we want to avoid heating, but if it does heat, what happens is some of the protein binds to some of the fibre in there, and both the protein becomes less available and the fibre becomes less available. So you do get a reduction in how useful that protein is. It tends to taste very sweet and animals like it, but you've lost energy, you've lost protein. If you are at all concerned that's been an issue with hay or with silage, you can ask for a test which effectively measures the amount of bound up protein, which the protein that's bound to the fibre, and therefore it's indigestible to animals, which means it's no longer useful either as a source of protein for the bugs in the rumen, for which to break down other fibre and grow, or as a protein for the animals later on. Got a couple of other questions here we might go through. How does barley grass in pasture impact silage quality? Good question. It depends entirely on the stage of maturity of the barley grass as to its quality. Earlier on, it's high in protein, high in energy, It's a good fee. Tends to be very low and difficult to cut. And I should have mentioned earlier, it's a bit like those drought stress crops when you've only got 2 tonne of material. I would strongly recommend not. They become a grazing option because the losses, once you go under 2 tonne, they can become quite excessive in terms of mechanical losses when you're cutting and raking and tedding and things like that. Assuming it's part of a pasture and it's not, it's going to be captured. The issue with barley grass comes in later on. If it has gone to head and it's a chopped silage, what can happen is animals can consume that and it gets caught in their mouth, and you'll get ulceration, you'll get bleeding of the gums and bleeding on the tongue and all the rest of it. Effectively, barley grass in silage, baled silage, is similar to barley grass in hay, in that it's not nice, it can cause problems in eyes and irritation, and if they eat it, can cause problems. If you ensile it, it doesn't appear to lose any of those barbs, it doesn't become any easier, and it still has the same or similar impacts to in hay. With baled silages, particularly sheep, seem to be able to avoid the barley grass to a degree, and it's not such a big practical issue. However, with cattle, if you have chopped silages and they're fed as a ration, it becomes difficult for them to avoid it. And if you look in the manual, you will see there's some pictures about which show the impact of barley grass, only a small proportion of barley grass in an open silage, which has led to quite severe mouth lesions and lacerations. So that's how I would treat barley grass. Effectively, if you've got a lot of barley grass, I would spray it out. However, if you've got a small amount of barley grass and you do cut it and put it in silage, it is probably going to lead to a reduction in barley grass the next year because you've taken those seeds away. Interestingly, we did have a little bit of data here when we looking at pasture and cutting and timing of cut and the impact on barley grass. And what we found was, early silage cuts seem to favour more subclover, but late cuts, early November cuts for hay, favoured barley grass. The barley grass had already set seed, and therefore you cut the clover didn't come back. There was a lot of barley grass. Now, that varied year to year, depending on season, with obvious differences between season on proportion. But I would say read the manual, treat it cautiously, but from a fermentation or quality point of view, cut early, there's nothing wrong with it. Also got one about Kikuyu pasture is best cut early summer rather than later. It doesn't really matter when you cut it in terms of time of the year. What matters is how mature it is. So if you've got, and this is the same pretty much for everything. Like I've mentioned cutting time. Probably what I should have made clearer, it's the maturity of the plant at the stage at which it's cut. So if it's vegetative, it's high quality. If it's reproductive, it's declining. If it's got seeds formed, it's quite low because all that goodness in the plant has gone into that seed head. With Kikuyu being a little bit different, you're looking at having something that's very leafy and trying to avoid having those stems in it. So you would manage, it would be more a case of managing that pasture to ensure you're not going to be cutting a lot of those sort of older, lower quality leaf and stolons. Other than that, timing is going to depend on whether you're more likely to get summer storms or not, and what's the easiest time to do it. But we'll look at some tricks like next week. But I know of people who can make Kikuyu silage in under a day, all things going well with tedding and a few little tricks, which we'll talk about in our next webinar. How long after opening a silage pit do you have before the silage starts to spoil? entirely dependent on the material. It can range from a couple of hours if it's bad maize, or if it's relatively unstable maize, to several days if it's a very stable silage like a lot of lucens are. We'll talk about that in detail and how to manage that in webinar 4, but essentially the things that make silage go off are exposure to air, the presence of substrates like sugar and ethanol that are really easily broken down, and when they break down at heat, and you have the presence of things like yeast and molds in sufficient numbers to start that heating process quite quickly. There is also management of the face to minimise that, but that's a longer topic. We'll talk about that later. And in terms the difference between haylage and silage, well, technically haylage is a trademarked product that refers to really dry silage. I think it was the stuff they used to put in harvest stores, but my explanation, or the way I can view haylage versus silage, is the one is just a dry variation of the other, which has very little fermentation and relies on effectively utilising packing it tightly, utilising any available air that's there, and sealing it so that it remains stable. Silage does the same thing, but you also have that fermentation, which leads to a pH decline. Can lead to some other issues in terms of protein breakdown and all the rest of it, but fermentation with silage, very little or no fermentation with haylage. So I have 7 minutes left. When did you want to come in, Sue?
Yep, I can come in now. So I'll just conclude some stuff, but so thank you, John, for your time and sharing your knowledge with us all. We've had some really fantastic questions today, and we're looking forward to answering some more of your questions in the next 3 weeks. With the mix of pastures and crops across the state, all with differing states of maturity, it's great to kind of get a practical understanding of when's the best time to make silage, and we really hope that you guys have enjoyed today's webinar. As I mentioned earlier, this is just the first of 4 webinars aimed at developing your understanding of silage production and use. And just a reminder, if you can't attend a live event, you can access the recordings of the webinar after each week's event, but you can only do this if you have registered. So thanks again, and we look forward to you joining us next week.
Thank you, Sue. Thanks, everyone. And sorry to those people who asked questions I didn't get to answer. Though quickly, there's 2 here. Can you make silage from medic or lucerne? The answer is yes. You can do a really good job if you wilt it. And my last slide there, if you need help, contact local land services. But thank you very much.
Thanks, John.
Welcome to today's second webinar in the silage series on mowing and wilting. I'm Sophia Cusick of the Education Team in Communication and Stakeholder Engagement at the Department of Planning, Industry and Environment, and I'll be your host for today. I'd like to acknowledge that as we are meeting across the state in this virtual space, each of us stand upon the lands of many different nations. I'm meeting on Gadigal land, and I'd like to acknowledge the traditional owners of the land and waterway of the Eora Nation and pay my respects to their elders past and present and emerging. I'd also like to acknowledge the traditional owners of the lands and waters on which our online audiences join us from, and pay respects to their elders past, present and emerging, and extend that to all First Nations colleagues and guests that may be joining us today. I'd now like to hand over to Sue Street, our Livestock Senior Land Services Officer within Central West Local Land Services, to introduce the session.
Thanks for that. Hi everyone, and welcome to the second in our series of webinars on silage. So today John Piltz will be talking about the mowing and wilting processes. So I'm sure hopefully a lot of you are either new today or have come back. So it's been great to see such a large number of people participating in these webinars. I also want to mention that the webinars today are brought to you by local land services, and that they were organised by the ag teams from across the state. Today we have John Piltz from New South Wales DPI to come and speak to you about the mowing and wilting process. So John has a long history with New South Wales DPI and was also one of the co-writers of the top fodder manual. So welcome, John. Thanks for coming for our second webinar.
Thank you, Sue, and thank you everyone online. Today, last week we looked at the impact of quality and timing of cut. Today we're going to look at mowing and wilting. I just want to start off, I've got 4 questions that have been sent in and we'll address those as we go through. But the first one was a request for a copy of any notes from the first session. Every bit of information that I'm using is pretty much contained within the Successful Silage Manual. So, as I said before, you can get that online. I'll show you where at the end again. Similar to last week, I'm going to start today's presentation by looking at a few definitions and a couple of pictures of equipment so that we're all using similar language. I'm also going to talk about the effect of wilting on livestock production, and then how can we speed up wilting rates, and finally have a session on how to measure dry matter practically in the field or at home. Again, please, questions as we go through are much appreciated. So firstly, these are probably all pretty simple, similar to what you people are using now, except for perhaps tedder or tedded. So a swath, when I say swath, I'm referring to forage left behind a mower or mower conditioner. A tedder is a machine which then spreads that mown forage out, and a tedded swath is what we refer to as the mown forage after it's been spread out. Whereas we'll tend to use the term windrow once that material has been pulled together, ready for harvesting, usually by a rake, which is designed for it, but sometimes some of the tedders are also capable of raking as well. I'm not going to get into too much discussion about machinery because there are a lot of people out there who sell machinery and know a lot more about it than I do. Also, equipment is changing all the time, and what the information I have here to show you is a little bit out of date, but I think it gives you the principles. This is essentially what a tedder looks like, and the tedder is the one that people probably ask most about. It's like a series of rotary mixers all lined up together. And what a tedder does is it takes all the mown material and spreads it out. So if you can imagine that those rotary wheels working, you can see that the material's fluffed up in the air, and you can see where all the material's loosely spread across the paddock rather than in a typical windrow at the time of cutting, or a swath at cutting. That's just another example of windrowing, and you can see again the material being thrown up in the air and spread out. Excuse me. So, mowers and mower conditioners. Right at many years ago, we all had drum mowers, and all they did was basically mow and leave a windrow like this. But increasingly, and I think just about everybody now uses a mower conditioner, which will tend to leave a swath more like this. I am asked occasionally, what's the best mower conditioner? And there's 2 main types. There's roller conditioners. This is one. And you can see in this instance, it's 2 rubber rollers that as the forage passes through, it's cut and passes through, it breaks up, compresses and crimps the forage. This is another roller conditioner with 1 metal and 1 rubber roller. The other type of roller, the other type of conditioner that you will see is called a flower conditioner. These tended to be a lot more prevalent down in places like Victoria, where they were used on mainly ryegrass pastures and the like. Now, they work by those tines, if you like, rapidly rotating and hitting the material as it goes through, damaging them. The whole purpose of trying to condition is to create essentially fracture lines on the plant material which allow for the moisture to leave the plant more easily. That's a close-up of another metal flow conditioner. Some are made out of nylon. And finally, you may also hear about high-performance mower conditioners or super conditioners, and there's a range of these. And they work by severely crimping the material. They may leave it in a windrow, they may leave it in a mat. And again, it's all about causing damage to the plant. And you can see on the right-hand side, you've got the little creases in the plant. That's an area where moisture can escape from the plant. And that's what we're all about. So last week when we talked about it, we looked at the fact that we need to achieve a dry matter content of between, say, 35 and 40 for chopped silage, and between 45, maybe 50, 55 for baled silage, and that we need to wilt the material to get up to that dry matter content. So, wilting. What's the impact of wilting on livestock? Well, this is some European data, which is a range of experiments, and it looks at the effect of wilting on intake and on live weight gain in beef cattle. So you'll see there that by wilting, you can increase intake on average by about 6.5%, but the range is quite significant, between 14 and 85% increase in intake by wilting. That's with cattle. If you look more closely to see what sort of impact that has on live weight gain, if you look at the average there, there's very little impact on wilting on live weight gain. And more importantly, the range is quite, either size. It goes from minus to a quarter of a kilo to a quarter of a kilo gain by wilting. So what we need to do is we need to say, what is it about wilting that enables us to achieve that live weight gain or intake and live weight gain improvement, as opposed to a net result which is pretty similar to an unwilted crop. This data combines a number of experiments and then does a prediction to look at the impact of dry matter content on dry matter intake. So how much an animal would eat. And these beef cattle. Most of this data would come from experiments with ryegrass, but a significant amount would also be from experiments that have some clover or some other pastures and crops. What you will notice there is there's a line going across saying 100. In Australia, we're pretty lucky in terms of weather. We're able to cut silages, wilt them, and we achieve a good fermentation by wilting, which is what we talked about last week. In many of the European countries, traditionally that hasn't been possible, either because they were making silages when the conditions were quite wet, they were cool, and they couldn't get a good wilt, combined with the fact that a number of the experiments from the past didn't have access to really good equipment that we do now to speed up the wilting process. So what in Europe, what a lot of silages were made with was they either added an acid or some other acid type product so that it effectively dropped the pH and you ended up with a good fermentation artificially. So where it says 100% intake unwilted silages, that's pretty much saying that we've created an unwilted silage by using an acid or some other additive so that the fermentation is not affecting or depressing intake, which is what we talked about last week. Poor fermentation, reduced intake, reduced production. What you'll see there, that as dry matter content goes from just over 20% to 55%, this combined data set predicts that as you increase dry matter content, intake increases up to about that 55%. Dry matter content of the silage, which is your baled silage, is at the top end, and you're getting about a 35% increase in intake compared to an unwilted silage. If we look at this a little bit more closely though, we'll see that the effect of dry matter content and intake will depend on what level of dry matter they achieve and also how long it takes to get there. So if we look at this graph, what's happened is we've predicted that what would happen at the bottom green line if we wilted the pasture, and again ryegrass, to 20% dry matter. What happens if we got there in 1 day and we get a slight improvement? If it takes longer than 1 day, it starts to decline, and by 2 days you actually reduced intake by taking that long but only achieving a 20% wilt. What you'll see with the yellow line or that above it is that if you get to 24%, you'll get a bigger improvement and 1 day wilting time. But if it takes 2 days to get it, you'll still get an improvement. However, you're on a decline. So the longer it takes to achieve your target dry matter content, the lower the dry matter intake is going to be. Now, if you consider that we want to make silages at about 35% dry matter, well, let's look at that blue line. You'll see that if we can get chopped silages wilted to the desired target dry matter in 1 day, we'll increase dry matter intake by about 35%. However, again, it drops. If we can get 45%, which is probably the bottom end of the target for baled silages, we'll actually get over 40% intake. However, what you will also notice is not only does it decline with the length of time it takes to wilt, that about 2 days appears to be the point at which it goes from a relatively rapid decline in intake or relative dry matter intake and starts to level off a bit. So this reason, along with a few others, we suggest that you need to wilt as quickly as possible and that 2 days should be the target as the longest period. I know that's not always easy. I know that at times the weather works against us and all the rest of it, but we'll look at ways that we can try and maximize that and maximize that wilting rate and achieve the target that we want. I have one slide here which I'm looking at the impact of wilting on lamb production. Now for relevance, this is Scandinavian data and it's grass pasture made into round bars. So applicable to what happens in Australia in terms of the production system and the storage system, individually wrapped round bars. Where it differs is at times they have great difficulty in wilting. So they've made silages with a dry matter content at 24%, 25%, or they've wilted it to just about 42%. Bit wetter than we would do, but it's not that dissimilar. And we do occasionally see silages at that dry matter content, so it does happen. Two things we'll notice initially is that the pH of the unwilted is not that low. Even though it's an unwilted silage, it's got a lot of moisture content, it's 5.44. That's sign of a dodgy fermentation, as we noticed last week, and the ammonia nitrogen is over 10, another sign of a dodgy fermentation. If we look at the wilted silage, however, you'll see that the pH is 5.9, not dissimilar to what we get here, and a much lower ammonia nitrogen content. The interesting thing to notice with that is that the sugar content, the WSC percentage of dry matter, is 2.1 in the unwilted, but it's still 10.1 in the wilted. That means the sugars equating to 8% of the dry matter that were in the unwilted silage have been fermented. Now, whether they've been fermented to lactic acid or other products, I can't guarantee. But I do know that with a pH of 5.44, that would have meant that silage would have undergone pretty ordinary fermentation, and my guess is that there's a significant amount of that sugar that's been wasted or converted into products other than lactic acid, potentially clostridial products like butyric acid, and what's more, the protein's been degraded. If we look at the impact on lamb production, you can see that unwilted versus wilted, lower versus higher intake, which is again that fermentation quality ammonia effect. Lamb live weight gain basically reflects the effect that intake of one is much higher than intake of other, remembering that this is a typical example where for the wilted silage, their intake is 920 grams a day, and for the other is 780 grams a day. 780 grams equates to a live weight gain of 114 grams per day. The additional intake between 780 and 920, 240 grams of silage, is going into production. All the maintenance requirements of those animals are already met, so that is going 100% into production. That's why you get such a massive increase in production for a proportionately smaller increase in intake. So our target is to reach, or our aim is to reach our target dry matter as soon as possible. Ideally, mow, wilt and harvest within 24 hours, preferably no longer than 48 hours, so that we're not losing that intake advantage. How do we do that? Well, there's a few logical and obvious steps. The first one is aim for periods of fine weather. We know light crops wilt more quickly. Wait till the dew to lift. A really heavy dew can equate to 1 to 2 tons of water across that crop per hectare, and so we don't want to have to dry it off after we've cut if we can dry it off while the crop's still standing. We can use a mower conditioner, leave wide rows, low density windrows, and use a tedder, preferably straight after mowing. Now, some of that sounds intuitive and some of it probably doesn't. The next point is sunshine provides more drying than wind. Now, we often talk about, and traditionally talk about, wind being important for drying, but it's actually direct sunlight that increases the wilting rate, much more so than wind. And the ideal is a nice sunny day with a bit of a wind or some breeze there to blow away any moisture that evaporates. Now, why? What I've got here is a picture of a leaf. So it's a cross-section of a leaf, if you can imagine, cut through. And what you will see is those little pores where the arrows are pointing, called stomates or stomata, and at this stage you can see from the one on the top they're actually open. While they're open, those plants are going to probably lose about 100 litres per tonne of material every hour. So effectively, what's happening in that plant is the same as when it was before it was cut. So it's still respiring away, and in theory, it's sucking moisture up out of the ground, and a certain amount of moisture is escaping. However, when those plants realize that they're losing moisture and they're not replacing it, they close those pores, they close those stomates, as plants do in hot, dry weather. As a way and a mechanism of conserving moisture within the plant, they close those. Now, that means that the rate of loss drops from, say, 100 litres per tonne per hour down to 20 litres per tonne per hour. The interesting thing is that only takes about half an hour to 2 hours to happen. So what we want to do is maximise the amount of moisture loss we can achieve while that period is still there, while the stomates are open. And I've just noticed a comment there that it's so much easier to make forage sorghum silage in January than ryegrass silage in August. Now, I'm guessing that's partly to do with the fact that it's a lot hotter and drier in in January than in August. But we might look at a couple of things relevant to that in a minute. So what do? First thing we do is we spread our swath out as much as we can. If we can achieve that 90 to 100% ground cover, we will achieve much faster wilting. The second thing we need to look at is we can TED. So this is a little tool that's become more common, which has a big impact. Previously, I said a couple of slides back that when those stomates are open, you lose 100 litres per hour. When you TED, you can increase that to at least 150 litres per hour. So when you're talking about, for example, making ryegrass silage in August, which is difficult, very difficult, we want every technique we can to try and speed that up. And one of the techniques that we've got is TEDing. Now, I've got some data which is probably quite relevant. This is a ryegrass crop. It's overseas data. So we've got something that's just under 4 tonnes of dry matter per hectare, and we cut it at 9 o'clock in the morning. You'll see there that if we mow and condition it and TED it twice daily, we've been able to achieve a dry matter content of over 40% within a day and a half. So from 9 o'clock in the morning to 2 o'clock the following afternoon. However, if we didn't do that, and we did what we used to do in the past, which was we cut a great big wide swath and we pulled it together and we left it sit there, that, if you can imagine a 6.6 metre mower with one swath, you'll see there that by 2 o'clock in the afternoon, we're only at about 23% dry matter content. So a major difference between leaving it in a swath versus TEDing it and mower conditioning. If you look at this next one, you'll see that we used a mower conditioner and we had a 2.5 metre cut and we left it at 50% wide. So we got an improvement. So by the next afternoon, we're getting close to fine chop, we're at 30%. However, if we use that same mower conditioner, 2.4 metre cut, and increase the width out to 1.6 metres, so not a big difference. We're over 35%. So what that clearly shows that if you take a set crop and how you manage that crop really has a major impact on how quickly that's going to wilt, how quickly it's going to dry. Now we have all these tools at our disposal. We can do all this sort of stuff. And to show that it isn't just an impact in ryegrass or impact in August or sometime like that, this is some data which was done down at Nowra on the south coast of New South Wales, and it looked at kikuyu grass in February from memory, which was either mown and left in a wide swath near mower width. Alternatively, it was just mowed and windrowed at the time of mowing. So no impact of TEDing, but purely and simply an impact of leaving it as wide as you can. Now what you'll see that initially those crops are about 12-13% dry matter content, but there's a marked difference in the rate at which they dry down. So to achieve 35% dry matter content by leaving the material out took 30 hours. So pretty easy to achieve a chopped silage within 2 days and meet our target. However, if we left it pulled together, we only got there after 54 hours. So we're not achieving our target of 2 days. Treatment 1, where we did all the extra work, we left it out. If we left it a little bit longer, we left it for our 2-hour period, we were nearly ready for baling. We're just over 40%. So huge difference again by just simply leaving it out and letting the sun get at it. What happens if we TED? Well, we looked at another 3 experiments, again kikuyu grass, In this case, we had the material left at the width of the mower and tedded once per 24-hour period, as opposed to a slow wilt, which was material left in a windrow and not tedded. So you'll see that under excellent drying conditions, on the left we've got the fast wilt treatment, and we've achieved over 30% dry matter content in 6 hours. And we started at slightly wetter than the time before, whereas we're still at 25% in slow wilt treatment. Now, if conditions get a little bit worse, like they were excellent drying conditions, nice, warm, sunny, dry, if it gets a little bit, if they're not so good, but they're average, in this case moderate drying conditions, in 2 experiments, the average of 2 experiments, where we started off with Kikuyu, it's again around that 13% dry matter content. You can see that after 30 hours we did meet our target 35 for chopped silage, and it took us 48 hours to only just get to about 32% for the slow wilted treatment, which is just left in a big windrow. So the points I'd like to take out of that are: first, mower condition it; second, spread it as wide as you can; and third, ted the material so it dries more quickly, so that you try and achieve everything in the pit within, or in the bar within 1 to 2 days. It should be the target all the time. Now, on that, there's a couple of questions I just want to, or points I'll bring up. Firstly, there was a question about tropical grasses, how making silage out of tropicals, and any tricks for ensiling tropicals. Well, tropicals have very low sugar content. So we talked about sugar last week, and sugar makes lactic acid. So more than anything else, with a low sugar product like a tropical, which has got less sugar than a clover even, you need to wilt that material as quickly as you can, but the trick is to make sure you achieve your target dry matter content, because if that material goes into the pit too wet, it will end up with a poor fermentation. It'll probably end up with a fermentation that may not be clostridial, but it's one that will produce a lot of acetic acid, be vinegary sort of smell, which means some loss of quality and some loss of palatability. That's probably the main trick for tropicals. Yes, they can be done, but do them as quickly as possible. And I'm aware of instances where people have been able to make Kikuyu silage, which is obviously a typical tropical, within 1 day for barling, by just working on it, wilting, wilting quickly, and mower conditioning. The other question I've got here is, can you make silage from clover about 20 centimetres high? And the answer is yes, you can, but the proviso I would put in when something's 20 centimetres high is make an assessment of whether or not you're going to lose a lot of that material by mowing, conditioning, tedding, and working on it. Whilst what I've told you is how to maximise wilting rates, which is good for crops that are, or pastures that have got a reasonable volume of material, usable density. If in fact you've got a crop or a pasture, and for example drought-stressed crops or very short pastures, very thin pastures, be aware that if you wilt, if you ted before, in part of your wilting, and then you need to rake it to pull it back in together again, you may experience quite a lot of loss. Now, we have a rule of thumb that says if it's under about 2 tonne, and this is based on very minimal sort of anecdotal evidence, if the yield is under about 2 tonne, you're probably better off to graze it. But if you need to make silage out of it, in that case, I would be suggesting you mower condition it and leave it reasonably wide, but you probably don't ted it, because the losses that you incur will be quite extensive during wilting, and potentially over 20 to 25% of the material will be just lost through, particularly when you rake it. This is another random question that comes up all the time. If I'm going to make silage, should I cut it in the afternoon because the sugars are higher? Yes, that's true. Sugars are higher. And there has been some American data that showed that if you cut in the afternoon to make hay, you will end up with a product that is a little bit more palatable for some livestock. But let's think about this. If we cut in the afternoon when the sugars are high, we're relying on the fact that if I go back, what happens is during the night, the plants basically respire those sugars for continuing growth, and the amount of sugar in the plant declines overnight. And then when the sun comes out the next day, it photosynthesizes and it produces more sugar. So you'll get this fluctuation whereby sugars are high in the afternoon, decline overnight, and start to build up in the morning. It's only going to happen if you've got a warm, sunny day. So if your conditions are a little bit overcast or a bit cloudy, you're probably not going to gain it. But probably the biggest concern is that if you cut in the afternoon, those plants are going to respire more overnight because they're still wetter. So essentially they're quite fresh. So you've cut earlier in the afternoon or mid-afternoon to capture those sugars, but the amount of respiration overnight could be quite significant. As opposed, if you cut in the morning and you cut, say, 10 o'clock or 9:30 when the dew's gone, sugars might be lower, but by the time you get to the mid-afternoon, if you've gone to the effort of mower conditioner, tedding, leaving the material out, and it's reached 30+% dry matter or higher, the amount of respiration that will occur overnight is probably going to be minimal. So that's one trade-off. The other trade-off is if you cut overnight, it may take you an extra day to wilt, which is not ideal because you want to get it done as quickly as you can. But again, we have to be a little bit practical because obviously most people will be in a situation where they will cut in the morning and they'll cut through to a certain time in the day and then potentially make silage the next day or the day after. If the paddock's really big, they may choose to keep cutting, or they might say, well, practically there's a limit to how much of that material I can bale or chop the harvest, so therefore I will cut a certain amount in one day and then a certain amount the following day and make it staggered in that way. The other thing I wanted to just bring up, remember last week we talked about losses and where about the losses fitted into the whole system, and we had effluent losses and storage losses and field losses, and you will see there that the field losses between the blue line and the brown line increase as you get drier. Well, this particular graph refers to lucerne. It's again in that manual if you want to look at it more detail. The interesting thing is, if you look at tedding and raking, and they've done it at 30, 40, and a range of dry matter contents, you'll see that both tedding and raking increase losses as the material becomes above 40% dry matter content. So now lucerne is obviously one of the more difficult plants because it's easy to fracture the leaf if it's a bit dry of the stem. But what you'll see there, if you look at tedding down the bottom, 30 and 40%, you're losing about 1% of the dry matter every time you do an operation. With raking, it's about 2% every time you do an operation. But once you exceed that, and for example, if you're raking at 50%, you're looking at 3% losses. If you're raking at 60%, and some people do go that high, you're looking at 6% losses. So my advice is, apart from the fact that don't go to 60% and try for that 45 to 50% for bales, in most circumstances put it in the windrow at around that 40% dry matter content or a little bit more, so that you don't run the risk of losing a lot of the material by raking later on. There's really probably no reason why anyone would want to ted that late, but they may want to rake that late. Now, those losses will be less for some pastures and some crops than for lucerne, but nevertheless, the general principle is the same. So, what we've talked about so far is achieving a dry matter content for a target wilting. The question that I'm often asked is that's very simple, but how do we determine what the actual dry matter content is? And there are a couple of ways to do that. And one in the field is we can take a sample, we can cut it up, and then we can squeeze it. What we find is and then we can release it and we can have a look at it. And we have a little bit of a gauge here which says that if it's really wet, less than 25%, when you squeeze that, you'll get moisture running through your fingers. We all know what that's like. However, if it's a bit wetter, 25 to 30, so still not where we want it at yet, it'll hold that shape and the moisture, there'll be moisture on the hand. And it'll probably effectively be a damp little ball. Where we want is sort of that 35 to 40%, and in the 30 to 40% range, the ball falls apart slowly and there's little or no moisture on your hands. And once we get to more than 40%, you'll find that springs apart, no moisture. And for chopped, it's certainly, you should be into it, and for baled, probably close. Now, that is an objective measure, but I would suggest to you, when you're feeling fairly proficient, you may be able to use that, but initially you might want a more objective test. For example, if you want to compare clover with cereal crop, you'll find that at the same dry matter content, they will feel different. The clover will compress more, it will feel wetter, whereas the cereal, because of its nature, will feel drier and it will spring apart more. So anyway, what do? Well, we can use a dry matter test. Now, for those of you unfamiliar with a dry matter test, there's probably the first rule, or the most important thing, is to just realize that if you don't do this properly, you're potentially going to burn your sample. And if you burn your sample, you're going to be in a lot of trouble. And if you do that in your kitchen, you won't get rid of the smell and you'll be in lots and lots of trouble. So what do? Similar to what we did before, and we take a representative sample. We chop it up and we weigh it. Now, for simplicity's sake, I would generally weigh out 100 grams. And that's 100 grams fresh. You can do it on your kitchen scales. You can do it anything that's reasonably accurate, probably at about a gram. You put it into the oven, the microwave oven, and you give it a bit of a blast. And you may do it for high power for a minute or high power for 30 seconds. Continue to do that while it feels damp and wet, and it'll get hot, and mix it up regularly so that you're exposing the material equally to the microwaves. You'll get to a stage though where the material will start to feel dry. At that stage, two things. Firstly, put a glass of cold water in and reduce the length and the power at which you dry the material. The reason being, microwaves can cause the material to catch alight. And if they're really dry, the material will catch alight, then you've got the disaster. If you've got a glass of cold water in there, that water will capture any spare microwaves running around, and so it won't be an issue. Couple of points though. Firstly, if that water starts to get hot, it'll start to steam. As it starts to steam, take it out, empty it out, put more cold water in, because all that will happen is you'll be creating a humid environment and the moisture will be reabsorbed. The second thing is continue to mix that material up so that you don't end up with all those dry bits out, so that they're hit first by the microwaves. When it feels dry, weigh it. Dry it for a bit longer, weigh it. When you get to a stage where it's really not changing in weight, So for example, you get to 35 grams and the next time it's close to 35 grams. Pretty much take it that that's the right answer, and that means 35 grams out of 100 grams, it's 35% dry matter content. Now, again though, just remember, that is quite critical. Make sure you put the water in, make sure it's cold, you don't have to put ice cubes in it, and that's a good way to go. Now, unlike last week, we seem to have gone through this fairly quickly, so I've got a couple more questions, and any more questions coming through would be greatly appreciated. Otherwise, we'll address these for a start. Now, one of the questions was preferred time from cutting to baling. I think we've pretty well covered that, and that is within 48 hours ideally. But if you can do it within 24 hours, that would be good. I'd like to also say again that all this material is available either on the DPI website or contact your local land services office, because they'll either have access to the material or they'll be able to contact somebody else who'll be able to get it for you. And they're a good centre for getting all this material. So on that, Sue, I'm actually finished the main slides that I wanted to go through today, and I suppose I could summarise by saying achieving a target dry matter content will end up with a better quality silage because of the fermentation, which we discussed last week, but also from an animal point of view, it will increase intake and palatability and production. However, to achieve that, we need to wilt as quickly as we can. We now have the tools that we can do that by mower conditioning and tedding. And there really is no reason why people aren't able to produce a good quality silage by wilting quickly. And I know in the past I've seen some classic examples. For example, Ikea silage baled within 12 hours. Silage is produced near Warrnambool in August in what's obviously a horrible climate in terms of drying, by simply using tools like mower conditioning and tedding and picking your weather and being prepared to put a little bit of effort into the wilting so that you end up with the silage you want. Now I have got a question here. Sheep seem to prefer drier silages, and I would agree with that. Sheep, I would typify sheep as being much fussier than cattle. Cattle seem to be more able to become accustomed to silage more quickly and more easily. Couple of tricks, I suppose. Firstly, if you consider that effectively what you're doing when you make silage, and it's a wetter silage, you're producing lactic acid, so it's going to be like yogurt. So it will be a little bit sour to taste. It won't be super sweet, whereas dry silages, which we touched on last week, are going to have more sugar left, so they will be more palatable. Some people love yogurt, other people don't. So it becomes a bit of a preference. Now, in terms of sheep, they don't seem to have that preference for that taste. Two ways you can do that. You can go down the drier silage pathway. The other thing that's worth trying is feeding stock. If you have some sheep that are accustomed to silage, feed lambs while they're still with their mothers, while they're still at foot, when they're a little bit older. And if the ewes will start to eat the silage, the lambs will start to eat the silage, and you'll see that they'll become accustomed to it and they'll do better on it. You'll probably also find that different silages sheep will probably take to a little bit more easily than others. Question, have seen people producing haylage, is this a good thing? I'm not going to say it's a bad thing, other than to say that haylage, if we take haylage at being more than 60% or 55 to 60% dry matter content, you will reduce quality because you will increase losses. However, it is possible to produce a product at 60, even 70% dry matter content that looks and smells quite fine, and the animals will do quite well on it. What you need to ask yourself is whether or not by producing it something at 60 or 70%, you're getting any animal intake and animal production benefit compared to producing at 50% and getting any losses and potentially better live weight gain or potentially better dry matter intake because it's higher quality. Difficult to say. It's a bit of a trade. My advice would always be go for closer to that 50%. It's because I can't see any real advantage from a fermentation point of view of being drier, but I can see losses being greater. So in summary, haulage can look and smell good, but I think that as best practice, you're better to go wetter. And in terms of what would you consider minimum temperature to wilt silage? Well, that's a good but interesting question, and to a degree, I'll cover myself by saying it depends a little bit on what your yield is. If we're talking about a pasture that's probably yielding, say, 3.5 tonne, I would have thought a fine, sunny, 25-degree day would have been sufficient to wilt that silage. Remembering, if we compare ourselves to, say, Europe, their temperatures when they make silage are not that dissimilar. We do need to be aware, though, that when it's 25 degrees, if it's 25 degrees and the day length's quite short, your exposure to sun's not that great. So we need to take that into account. And if you're in a year where you're getting really heavy dews, so it's dripping wet every morning, then you're also going to have a problem. Therefore, assuming dry, a moderately yielding pasture and everything else in your favour, or a cereal crop or something, I would think 25 degrees. If you can get 25 degrees and you've got the equipment to mow, condition and also ted, you would be able to make silage. If, however, you were talking about a cereal crop which had about 10 tonnes of dry matter and we're in a really wet year, I think you would really, really struggle. And then it becomes a trade-off in people's minds. So, for example, I know that there are some people at the moment that are very concerned about the fact that the growth on cereal crops is much more than they would like to see them, and they're much more mature than they would like to see for this time of year. So can we cut those crops and produce silage, and effectively it's a mechanical grazing? And I would say back in May we probably could have got away with it, but between May and now it's been too cool, the days have been too short, the dews have been too big, they've been too heavy, and the temperature's been too low. Now, whether that'll change in the next 3 weeks or 2 weeks, or how much it will change, I don't know. It's a nice sunny day out there at the moment where I am, but it's still only going to get to probably 16 or 17 degrees. So and the days are still going to be fairly short. I would think you would struggle. But if you're in an area that's a little bit further or more conducive to for longer days, dry weather, you probably can get away with it in a couple of weeks. But we would normally say September's probably as early as most people would be able to go under most circumstances. Well, the question about the increase in dry matter intake with dry silages, how much is it due to animals bulking out on water? I'm not sure to how much. Certainly at those really wet levels, I would expect the water level to have been an issue, but I can't give you a proportion. And I can't tell you whether or not there's a point in time where there's some palatability thing that takes over as opposed to the amount of water. For those who probably aren't aware, too much pastures that are very, very luscious, then you've got a lot of water, and that water can actually reduce intake. So in most beef and sheep enterprises, not a major deal, but certainly in the dairy industry, very lush wet pastures are a problem because the amount of water depresses intake. Can you get more tonnes in a pit at higher dry matters and a more stable pit, bales? No, you probably can't get more tonnes in a pit at higher dry matters because if anything, it's probably going to be harder to pack. It depends a little bit on what you mean by dry, but if you're 35 to 40% in, say, a clover, you probably pack it very well. You will get some, it may become more difficult after that, but if it's, for example, a cereal and the chop length is a little bit longer, at 40% that'll be quite difficult to pack because it's quite spongy and bulky. So in a pit, chop length, chop silages, too dry, you poor compaction. However, the next part there is and a more stable pit with bales. Bales do all the compaction for you, so they really you don't have the issues of running backwards on a tractor and something that's spongy and it's not going to compact easily. It's all done for you. So the higher dry matter content isn't really an issue in terms of compaction for square bales, which I'm assuming most people will use now. As to whether or not that is more or less stable, in the pit itself, provided there's no air gets in and no moisture gets in, it's going to be the same. However, when you open that up, one of the issues will be one of the issues in terms of how quickly that goes off will be how much free sugar is still left in those crops. So if you can imagine that when we cut a plant, a certain amount is converted to acid, chopped silage, preserved. The drier we get, which is sort of what we talked about last week, the drier we get, the less of that sugar is converted into acid, till we get to a point that around 50% dry matter content, there's very little fermentation, so there's very little fermentation of that sugar to acid. The sugar is what's most readily broken down and causes heating and instability at a pit. So simple answer is dry silages may be less stable because they have higher sugar contents than wetter silages because they have lower fermentation. In terms of pits, it's probably hard to adjust that too much because even lower dry matter baled silages are still going to have reasonable sugar levels. It's probably going to be more the material that you put in is going to determine that. So something like a high sugar cereal or a high sugar ryegrass will be less stable, whereas a lucerne or a clover I would expect to be quite stable for quite a few days. Sue, it looks like I'm running out of questions, so should I turn over to you now?
Thank you so much for that, John. Some really, really fantastic questions there. And I hope you all got something out of the webinar today, and that you will all continue to join us for these webinars. So thank you so much, John, for all your wonderful information today.